Hi, it's Mrs. Moret with help on the Lesson 5 practice problems from your textbook on page 36, numbers 1 through 6. So let's get started. For number 1, write each expression in the form a to the b without using any radicals. So a is going to be our base. So for this first one, I know the square root. That's going to give me an exponent of 1/2. And so this is equal to what's inside the square root, 5 to the ninth, and then to the 1/2. So we're almost there. We're in between. And now what I need to do is simplify that a little bit more by raising that power to a power, so multiplying the exponents. So the base is still 5, and then 9 times 1/2. So 5 to the 9/2. On part B, very similar idea. I know that this is equal to, I'll just rewrite the cubed root of 12 using an exponent. So it's equal to 1 over 12 to the 1/3. And then I'm almost there. Because it's a fraction, 1 over 12 to the 1/3, then I can write it like this and make the exponent negative. So 12 to the negative 1/3. All right, so those are finished. Number 2, write 3 to the negative 2/5 without using exponents or radicals. So we're just going to actually find its value. So 32 happens to be a power of 2, so that's really helpful. If you know some of your lower power rules or math facts, that's really helpful in simplifying things like this. But I'm just going to kind of write it out step by step. So I've got 32 to the negative 2/5. And the first thing I'm going to do is address the negative in the exponent. So it's equal to 1 over 32 to the 2/5. Okay? And so I can take that 2/5 and say, oh, well, then it's the fifth root, right? Because 5 is the denominator of that fraction exponent. So I'm going to rewrite this now as 1 over the fifth root of 32, but that's squared because of the 2 in the numerator. Now, the fifth root of 32 is equal to 2 because 2 to the fifth equals 32. And so going backwards, the fifth root of 32 is 2. Okay, so again, if you kind of know some of these powers of some of the lower numbers, like especially 2 and 3, then that's really helpful in simplifying problems like this. So I can rewrite the fifth root of 32 as just a 2. So this is equal to 1 over 2 to the second. And finally, 2 to the second is equal to 4. So the final answer on number 2 is 1/4. All right, number 3 is a matching exercise. And so I'm just going to simplify each of these. So I know that the 1/3 exponent means we're using a cubed root. So A, this is equal to the cubed root of 8. And the cubed root of 8 is equal to 2. Okay, so that's that one. Now I can kind of go, oh, I just did 8 to the positive 1/3. So to the negative 1/3 is the same thing, only it's the same root, only in a fraction, right? So that's equal to 1 over the cubed root of 8. And since the cubed root of 8 is 2, this is equal to 1/2. So B is 1/2. And then C, 8 to the negative 1. So that's going to be just a fraction, 1/8. And next one, 16 to the 1/2. So that fraction exponent, 1/2, means we're using a root, a square root. and the square root of 16 is 4. And then following the thinking that we did above, what if the 1/2 exponent is negative 1/2? Now it's just going to be a fraction. 1 over the square root of 16, which is equal to 1/4. And then finally, 16 to the 0, well, anything to the 0 power is equal to 1. All right, in number 3, or sorry, that was number 3, number 4. Number 4, we have a little table. We're using powers of 27 in the top row and radicals or rational numbers in the bottom row. So our bottom row answers are either going to be radicals like that or rational numbers. Whole numbers and fractions are both rational numbers. All right, so the first set has been done for us. Up here, if I'm going to write the square root of 27 using an exponent as a power of 27, that means 27 to the 1/2. And then the next one, 27 to the 1/3. Writing that with a radical is going to be the cubed root of 27. But the cubed root of 27 is actually equal to 3. So that can be simplified all the way to a 3. How would we have gotten 1 from a power of 27? Well, it must have been 27 to the 0, because any value to the 0 power is equal to 1. And on the next one, 27 to the negative 1/2. So we have 27 to the 1/2 over here is equal to the square root of 27. So then to the negative 1/2 is going to be 1 over the square root of 27. All right. And then the 1/3. How could we write 27 to a power and have it equal 1/3? Well, here 27 to the 1/3 was eventually equal to 3. And so how could we get it to be 1/3? We could get it to be 1/3 by putting a negative in front of the fraction exponent. So negative exponents make fractions. Fraction exponents make roots. Negative exponents make fractions. Fraction exponents make roots. Okay, that's a kind of a tough one to remember. You got to get that down. All right, here we go. Number 5. Number 5 is a review from Unit 2. And I thought the easiest way that I taught you to solve problems like this was to graph them. So I've got Desmos here on my little calculator, on my phone. And I put the left side of the equation into the first row. It's a parabola. And then y equals negative 2 into the second row. It's a horizontal line. And then I can zoom in and click the points of intersection, and I'm looking for the x values. So I know the two solutions to this equation are x equals negative 1 and x equals 0, because those are both the values of the function that make it equal negative 2. And then finally, number 6, use exponent rules to explain why these are equal. So having the cubed root of 5, the square root of 5, and then raised to the third, as opposed to the square root of 5 to the third. Okay, how can we explain that they're equal? So I wrote this out on the answer key, but I'll explain it as well. I'm going to be able to show that they're both equal to the same value using fraction exponents. Okay, so give me a second to kind of get us there. So I'll start with the first expression. So inside parentheses, the square root of 5, and then outside, raised to the power of 3. Well, I can rewrite the square root of 5 as 5 to the 1/2. So if I say, oh, well, this is the same as 5 to the 1/2 and then to the third. Okay. And now I can use the power to a power property of exponents to say, oh, when you raise a power to a power, the base stays the same and you multiply the exponents. So then this is equal to 5. 1/2 times 3 is 3/2. Okay. So I'll color code this. So that was the work on that expression. And now if I work on this expression, I'll say, okay, so the square root of 5 to the third, and that power exponent is under the radical. Well, I'm going to change this as 5 to the third raised to the 1/2. Okay, so I took the radical and rewrote it using an exponent. So instead of square root, I have a power of 1/2. Still on 5 to the third though, okay? So same as above, when you raise a power to a power, the base stays the same, and you multiply the exponents. 3 times 1/2, again, is equal to 3/2. Okay, so by that, isn't that called the transitive property of equality that you learned in geometry last year? If I can say, oh, well, look at this. They are both equal to 5 to the 3/2. So must be equal to each other. Oops, that's outside the window. There we go. Okay, if they're both equal to 5 to the 3/2, they must then both be equal to each other. So again, that was the transitive property of equality that you learned in in geometry last year. All right, I hope that was helpful. That's the end of the assignment. Thanks for your hard work.